Hello, hello. Welcome to the April Community Standup for Blazor. Today we're going to be talking about Blazorators, sorry. And we have with us David Pine. Hi, David.
Hi, friends.
And we have the one and only John Galloway, who's going to be our co-host today. Hi, John.
Hello, happy to be here. I'm a fan of Blazor. I'm a fan of source generators, and I'm a big fan of David Pine, so I'm really excited about today's show.
Should be great. And my name is Tanay. I am on the Blazor team at Microsoft. So the way we're structuring it today is pretty straightforward. We're going to start off with some community links, just going to talk about some stuff that's happening within the community, links and resources that you may find interesting. And from there, we'll jump right into Blazorators with David Pine. So let's get started. Let me share my screen. Cool. So these are the community links for April. The first link here is a write-up by Jeremy, who talks about how to run EF core queries on SQL Server from Blazor WebAssembly. So EF core is Entity Framework Core, and it allows you to better interface with databases and so on. So this article provides a really in-depth overview of how to integrate with between EF core and Blazor WebAssembly, things that you want to watch out for while you're doing it, and a bunch of really great packages, APIs, and so on that you can use to take advantage of all these great services. Okay, that's basically it for this link. The next link here is just kind of an announcement post for Fluent UI, which is a library for a bunch of different frameworks. They also have Blazor integration. And recently they released a new package. It's Microsoft.fast.templates.fluent UI, which has a bunch of great changes. Namely, they are now supporting project templates. So I believe if you scroll down here, if you go into VS, you can start off and just create a Fluent UI template directly from Visual Studio. You don't have to do additional integrations and all that kind of stuff. So it makes it really, really easy to get started with Fluent UI and Fast Design and so on. So if you aren't familiar with it, there's also the Fast Design website, which gives you a great overview of what all that entails and why you may want to be using it. And of course, this is on GitHub. So if you want to learn more, see the code behind it and so on, you can of course do that as well. Cool. Next link here is from Auth0. This is just an overview link on how exactly you can integrate between Blazor WebAssembly and Auth0. So the APIs that you can use, as well as the packages and so on that you need to integrate with, and they take you through essentially creating an application using Auth0 and see all the integration points and that kind of stuff, so you can get started quickly and integrate authentication within your app. So if this is something you're interested in, definitely check this out. And lastly, we have a game. This is kind of just like a periodic table game that's built using Blazor WebAssembly and Fluxor. And you can choose a bunch of different stuff. For example, it tells you an element, you have to find it on the periodic table. Or likewise, if you go to place a symbol, you get an element and you have to figure out where it stands on the table and so on. So just a really fun little interactive game that shows you like Blazor isn't necessarily just for a certain type of application or a certain application domain. It's really flexible in what it can do and what you can achieve with it. So really, you can do whatever you want with it. Cool. That's basically it for the community links. I don't want to take up too much time with that because I want to hand it off to David Pine, who's going to be showing us a lot of wonderful stuff with Blazorators. So let me share your screen, David. Okay.
Awesome. Thank you so much, Tanay. And to all of our live viewers today, I just want to say I'm super excited to be here. So if at any point you have questions, please do ask them in chat, and John and Tanay will try their best to make sure that I get a chance to address them. So welcome to a talk about Blazorators. Since we're developers, we're good at naming things, right? So this is basically taking Blazor and Source Generators, which is a C# Roslyn API-based approach to source generation. And this has been a labor of love. It's a side project. So my name is David Pine. I'm a host of on .NET Live. We're going to be revamping that here in May. So look forward to that. I work in DevRel at Microsoft. You can follow me on Twitter at DavidPine7 or Blazor Bits, where I share information about Blazor. All of my source code is open on iEvangelist on GitHub. And if you're interested in any of my old blogs, I don't do much anymore there, but davidpine.net. So Blazorators, I had some design goals, and to take a step back and kind of discuss the vantage point was last fall, Microsoft hosted an internal hackathon that was open to MVPs. So myself and an MVP hacked on the idea of generating Blazor JavaScript interop code based on TypeScript type declarations. So I knew that TypeScript was the way to go because it provides type declarations around all of the APIs that exist for well-known JavaScript APIs. So the idea was to, point to either a file on disk or a remote URL that would then resolve to a TypeScript type declaration. And then using that declaration, kind of brute force parse it. And then once you have it in .NET and you've parsed it out and you kind of have like the abstract syntax tree or the node or the hierarchy or, the interface, the different contracts for these APIs. Once you have that, then you could use C#'s, source generators. So the idea and design goals was to target partial interfaces and then create implementations for those interfaces. And I wanted to support generics, and we wanted to have support for custom serialization. And there's lots of other things that you have to consider, like callbacks and parameters and return types. And if TypeScript type declaration shows those different types, we have a way to go then look them up and then build out those corresponding types. A lot of times it's just simple, plain old class objects. And then to add, icing on the cake is to auto-generate the dependency injection hooks for all this stuff. So that was kind of like the top level goals. In addition to that, we wanted to keep it simple. And that's kind of hard to do because there's a lot of parsing of various strings. So I've been actually exploring the potential for potentially re-implementing the TypeScript compiler's parser to have like a better understanding of how all the stuff flows, but that's a lot of work. So this is where the community comes in. So ideally, I'd love to make this extensible so that the developer community can get excited by it and see that, hey, we can generate, any arbitrary JavaScript APIs given a parser. And in this case, the default one right now is the type declaration parser. But some community members are looking to implement Web IDL, which is a different specification for how some of those APIs are surfaced. In addition to that, there's other folks that are trying to use it for JavaScript APIs that are proprietary, internal things. So there's lots of use cases once the source generator itself is kind of put together. People love that it's relying on TypeScript. I'm a huge proponent of TypeScript. I've been speaking about TypeScript for a long time now. So people like the name. Regulators, anyone? No. So yeah, there's lots of community members that are, supportive of this. So I would love to invite all of you that are watching to, post an issue, propose a feature, take a look at some of the packages that are there, and help me, because I'm just a single developer with this little side project that was initially a hackathon. So all of this is backed by building a case for source generators. And so source generators in the context of this, to me, it just makes sense, right? So if you have JavaScript APIs that are well-defined, why would you want to spend time as a developer writing the interop code? You have more interesting problems to solve, right? So those APIs are there. It'd be nice if you could just generate them and then consume them and then do the interesting things. So the way source generators work is you have your code here in this little green box, and you're typing your code, and the C# compiler sees your code and it does some stuff on it, and there's n number of analyzers. So any number of analyzers that sit there. And analyzers are actually the way that source generators work. Your code is, like my source generator is actually considered an analyzer. And it has the ability to output generated source. And that source then becomes part of the compilation context for your code and the source generated code. So the compiler sees that and it just does the whole thing over again. So you have the ability with source generators to kind of, create additional source. And the particular case of Blazorators, so when you compile, I actually source generate some attributes, and these attributes are available to the consumers of the Blazor.sourceGenerator project. And with those attributes, if you decorate a specific type and you say that you have a type name, so you're targeting a very specific interface, you can then conditionally, generate the additional stuff. So in this case, if there is a valid source to generate, you'll generate the interface, the implementation, the DI hooks, and the dependent types. And then that just goes back into the standard compilation. And then your compilation is done. So one very common example, if you've ever done any Blazor JavaScript interop, you've probably seen local storage. There's many packages that exist out there, but this is just one example to kind of show like the bare bones minimum of what source generation can do for us. So inside the libdom declaration file at line 14,276, very specific, right? This is all open source. It's Microsoft TypeScript. It's in the main lib, but this interface is defined. So it's interface of storage. It's got a read-only length, which is a number. It's got a clear method. It's got a get item given a key and string that returns. In this case, we would convert a string union type of null to just a nullable string, right? Key given the index, same thing. Remove item given the key, and that's just void returning. Set item given the key, and then the value for string void. So what would that look like in C#? So there's two different things that you have to be mindful of. If you're going to use WebAssembly, you have some potential performance benefits in choosing the IJSInProcessRuntime. Because in WebAssembly, since it's on the client, the JavaScript interop is actually in process. So it can be synchronous rather than asynchronous. And so that's the client-side execution model versus, any Blazor format, which is the async API. So we can generate both of those. So here's an example of what this might look like for WebAssembly. You'd end up with an interface that is length, which is a get only, clear, T value for get item. And we've got a way to actually support generic, so we can specify that we want the return of the get item to be generic. And then we actually provide overloads for serialization. So you can pass in your own custom JSON serializer options. If you don't provide any, right, we have defaults that we fall back on. The same is true for the set item. And then you've got key and remove item. So how might you actually implement that? So that's kind of the responsibility of the source generator. The source generator actually generates all of this code and the corresponding implementation. So as you might imagine, if we were targeting WebAssembly, we would generate it, a default local storage service that takes on a dependency through the constructor of the IJSInProcessRuntime. And then it just delegates out to the corresponding APIs in JavaScript. So I'll show you what that looks like in the demo here in a little bit. Likewise, if you're doing the async versions, the API changes such that it's value task returning, and then you have the async prefix, but it's basically the same shape, right? So what if we were to do like in a more elaborate example, like geolocation? So geolocation's interesting. Even though it has fewer methods, it actually has this notion of callbacks. So with Blazor, you can do bidirectional interop. So you can call from .NET into JavaScript. Likewise, given a reference or a static method to call back on, you can call from JavaScript into .NET. So it's really, really compelling. So, clear watch given a watch ID, that's pretty straightforward. Get the current position. This is where things get a little bit more, inquisitive. So we have a success callback. And, this is very common in JavaScript. There's all sorts of callbacks, right? And then we've got optional callbacks. So get current position accepts either a position callback or an error, or additionally an error callback. So let's go to the next slide here. And as you can see, the position callback, that's an actual type also. So when the source generator is generating the interface for geolocation, it has to then, look up the position callback type itself. And that is another type that exists in this file as well. So if we go find position callback, we can see that it's just basically a method. The callback accepts a position, which is a geolocation position object. And then we have to go look up that as well, right? The geolocation position is a little interface that's got a coordinates, which is a geolocation coordinates object, and then a timestamp, which is a DOM timestamp. So DOM timestamps, there's not really a type that, is friendly to convert over from, JavaScript or TypeScript to .NET. In this case, we would just use a long, because the DOM timestamp is actually a number, and that's the milliseconds past Unix epoch. So the source generator is smart enough to see these types and add read-only date time objects that do the math for you. So as a convenience, you get all of this stuff. You get, serialization support, generic support, you get the entire dependency, you get callback semantics, you get lots of really fun things, right? And so this is the shape of like the geolocation coordinates. So we would generate an object called geolocation coordinates that has all these properties using idiomatic C#, right? So you get the names as you'd expect them. Accuracy, for example, that is a read-only property with a capital A, right? So here's an example of just the get current position. So with Blazor, if you've done JavaScript interop, you know that when you want JavaScript to call back into .NET, you have to create an object, like a .NET object reference, given some sort of component or some other thing that has a method that is JS invocable. So this might be an example of one potential interface implementation. Another one, which is more idiomatic to C# that you would hope to see, is just using actions rather than the name and like a JS invocable and all of that stuff. Just, what if the service could just generate this kind of code that says get current location given the callback, and that callback matches basically one-to-one with what the JavaScript APIs do. And that's what you end up getting. So even the / comments are source generated. So all of the implementations, all of the interfaces, all of the dependency hooks, everything there is very, very empowering to the developer, the consumer of these packages, because it builds out / comments and all those things. So let's jump into a demo, and I will show you.
Let me try and see if I followed along on your slide so far. I'll try and also we had some raiders and stuff jumping in partway through. So just kind of summarizing what I've heard. So Blazor is super awesome. It's a browser standard, runs in the browser. It runs C#, not JavaScript.
Mm-hmm.
There's a lot of other cool things that browsers can do, geolocation, local storage. The sky's the limit, and there's tons of JavaScript libraries out there that we could call into also.
Mm-hmm.
But to do that, we have to use JSInterop, which requires writing some code and going in and reading the specs or reading and converting types and stuff. I've messed with that in the past. It's a pain. So wouldn't it be great if we could automate that? And so the genius moment you've got here is use the TypeScript definitions, which are published, and have those actual, like the contracts written up, the interfaces, the data types. And with that, you can generate both C# and JavaScript code, or I guess just C# code needed to call into the JavaScript.
That's a really good distinction. Yeah, as of right now, it's limited to C#. However, there are plans to also source generate the corresponding JavaScript, because there are some times where you might want to intercept or, delegate or orchestrate some sort of call chain differently. So it would be nice to have control over that. So yeah, there are plans to add JavaScript as well, because it is pretty close, right? TypeScript, read it out, and then why not? You're pretty close already. So yeah.
Yeah. This is just personal story on this, but I played with some stuff with Blazor before, and I wanted to do some audio processing, and I looked at some libraries out there, Howler.js and some others. And then I started looking at like, okay, I can do this JSInterop stuff to call into the library. And this was before source generators were out. And I was like, wouldn't it be neat to like, just, run a process that generates a bunch of code? I started looking at it. I was like, this is harder than I thought it was going to be. And then it was like, let's put that on my list of stuff to look at someday. So I'm glad that you've solved this problem for me.
Well, at least temporarily, and kind of a potentially hacky way. There are, like I said, there's this is a call to action for all the community members watching right now. I need help, right? There's a lot of stuff. This is just like, the initial little bits, the result of a postmortem from a hackathon. So there's a lot more work that can be done here to make this a lot better. But it's doing some cool things already.
Cool.
So let's share the other screen. Yeah, here we go.
Cool.
All right, so in here we've got, this is the Blazorators solution. As of right now, it's 15 projects. The core library is the Blazor Source Generators, and this is just a standard Roslyn source generator. So the JavaScript interop generator is a subclass of ISourceGenerator, and this class is decorated with the generator attribute. So this basically provides two different hooks. There's an initialize, which is the generator initialization context. And from this context, we can register for syntax notifications. And this is when we start getting into the meat of some of the Roslyn APIs, because there's a lot of stuff that goes on here. So we've got a JavaScript interop syntax context receiver. So this will basically build out a few different things. Let's jump into that real quick. So what it does is it will kind of register this syntax context, syntax node visit. And what it does is, as the compiler is building out all the source and it's waking up the analyzer and it's detecting things, we can use this to reason about what the developer has intended to do. So this source generator actually creates a few different things that it emits. So it emits 2 attributes. One attribute is the JS auto interop attribute. And this is just a big string blob that contains the actual C# source code itself for this attribute. And then you have like the type name, you've got the implementation, you've got a few other options here, different hosting models, things of that nature. And then there's one for generics as well. So these are part of like the compilation context. So they're generated, and then once you're consuming the generator, you can use these attributes. And once these attributes are used, then the syntax receiver will see that they're being used, and it builds out some declarations that it will then pass back to the generator itself to reason about your intentions. So in here, there's lots of things. There's
the code you're showing all so far here is code you've written,
yes.
So I don't have to write it.
Right.
And
yeah.
One thing I thought that's interesting with this, and you talked about that there's just a lot of work that goes into it, but some of the files you showed there are just big strings. Like they're just, and so you're basically like your logic here in this file, going through, reading the attributes, figuring out what it needs to do. And then in those cases is just saying like, here's the template string, let's just dump that in there, right?
Yep. And that's really just for the 2, kind of declarative attributes that will then trigger the actual source generation. So we haven't even gotten into the meat of like the actual generation stuff yet. So I'll show you, let's jump over to now local storage. So inside local storage, it's blazor.localstorage.webassembly. The only source code in here in this entire project is this 17 lines, which is a public partial, I can zoom in too, let me zoom in, bump that up. It's a public partial interface, local storage service. And this is one of the auto-generated or source-generated rather attributes. So this is JS auto generic interop. So we specify our like target type name as storage. So this is, if you're to go look in that definition file, for example, inside the libdom, you can actually find the interface that we looked at before in the slides for storage. And we say that the corresponding implementation is window.local storage. So it's very easy to imagine, well, with storage, there's actually 2 different implementations. There's a local storage and there's a session storage. So I've got another package down here that does the same thing, but it varies simply by saying I want session storage, right? And these will generate 2 entirely different implementations. So it's kind of neat. So this is the interface, and here's the cool thing. So with analyzers and source generators, you can look at the dependencies analyzers, and you can actually see the output for the source generator stuff. So this is all the stuff that was generated from the source generator. So we have the corresponding other partial. So this is the other half to the partial that was source generated for the interface. So you can see we get a void clear, and it's got API docs too that are source generated for you. You get the T value, get item. Here's the generic type. We get the overloads for serialization, key for the index, remove, so on and so forth. And then the actual implementation itself, well, that's an internal sealed class. And the reason is I don't want to leak the implementation. So dependency injection is fine with us, just wiring these 2 things up, saying that the iLocal storage service has a corresponding local storage implementation. So I dependency inject into this, the IJSInProcessRuntime, and then we end up just delegating out. So it's an explicit interface implementation. So the iLocal storage service.clear goes to JavaScript invoke void. and that's just window.localstorage.clear. And then for getting the item, we've got extension methods and serialization, custom stuff there. So I've got, from JSON, given the type and the options, because this API just returns a string, right? So, and then here we've got the key, we've got removal, we've got the setting of the stuff, and we've got like evals for properties, things of that nature. So this is, you could write this all by yourself and it would be, pretty straightforward. But it's nice to just be able to kind of have a source generator do it for you, especially as things evolve. Or imagine even getting into a scenario where we say, well, we want to target different versions of the ECMAScript standard, right? Imagine we add an option here that says, let's target this version. So then you get versioned .NET APIs that correspond to different ECMAScript standards, right? The sky's the limit. You can do all sorts of stuff. So additionally, we source generate the local storage service collections extensions. And this basically just adds dependency injection for us. So it's called add local storage services. It adds a singleton. So this is just basically kind of a helper to get the IJSInProcessRuntime, because that inside WebAssembly, it comes from the IJSRuntime. It's just a subclass of it. And then we do singletons for the local storage service. So then all of that code comes together and it is consumed inside this example project here. So I've got add local storage services. I've got I'm doing session storage.
So,
and
at this point, up till now, you've been showing the code you wrote.
Mm-hmm.
At this point, we're switching over to, and partly if you're watching this and this is like, whoa, this is a lot of stuff. This is the easy part, right? This is the code that you write in your application so you can take advantage of it.
Yeah. So this is just the consuming part. But also, excluding this here, all three of these right here are source generated. This one I wrote by hand just to kind of model things out. But like local storage, session storage, speech synthesis, geolocation, those are all written, or rather those are packages that are consumed here that are entirely source generated. So it becomes very, very compelling. So let's take a look now at the iGeolocation service. So this is even fewer lines. Remember the last one was 17, this one's 12. It's saying JS auto interop. The target type is geolocation. The corresponding implementation is window navigator geolocation, and that's the docs for it. The corresponding outputting source generated stuff here, there's a lot more you can see than the previous one. And the reason for that is because there's all these callbacks. So it has to figure out what else to build. So let's see, clear watch is pretty straightforward. But then get current position. So this is where we need a component reference. And you can see even the source generated / comments are smart enough to tell the consumer of this exactly how to use it. So if they're to use this interface to get it dependency injected, they can say, dot get current position. They're expected to pass in a component, which is constrained generically to a class. They're expected to give an unsuccessful callback method name. So this is just the name of the method. But if you look at the parameter definition here, it's source generated to say that it expects the name of a JS invocable attribute C# method with the following signature, right? An action of geolocation position. And that would just work. But that's not really idiomatic. So you might want to use actions. And this is where you can actually use the action to get that. So then you can just say on current position, give me your Lambda expression, and then you'll get a geolocation position. And it comes together really, really cleanly. So the geolocation position, if we go look at that, you can see it's doing JS property name stuff for you. It's assigning defaults. It supports nullables and all of those things. And this is what I was talking about earlier. Like the timestamp is actually a DOM timestamp. So that's just a long. But I also have extension methods in this library that help provide convenience-based things. So it's timestamp as UTC date time. And then from this, you can just say, to local time, or datetime, and then you have your local datetime. You know, it's really, I think, cool. And that's just, you know, my biased opinion. But yeah, all
That's
of that
awesome.
is built out. Let's see here. I don't know if there's any questions specifically inside this part, but I could show you the.
So I have a question for this. So previously you showed us, say, how you're casting into the IJS in process runtime and so on. So that was for the Blazor WebAssembly bits. But from my understanding, Blazor server is also supported for this?
Yeah. So let's go look at that one. So if it doesn't have the .WebAssembly, those packages mean that they're targeting, you know, just kind of Blazor holistically. This Blazor hosting model, this is actually source generated as well. So it's either server or WebAssembly. It defaults to WebAssembly because, you know, in part, I'm writing a book about Blazor WebAssembly, so I wanted to kind of focus on that. But it also supports server scenarios. So the code that it generates for that is a little bit different, but it doesn't vary too much. So let's go look at the interface. So that's actually the implementation. Give me 1 second. The interface here, it makes everything then instead value task based, and it adds async for the suffix. So it's the same API surface area, the same types are generated, all that stuff, but the interface itself is asynchronous, and the corresponding implementation is IJSRuntime rather than the IJSInProcessRuntime. And then, as you know, those are async APIs.
Okay, makes sense. Yeah. It's great that you're able to take advantage of different synchronous runtimes based on Blazor server and WebAssembly. So like you aren't restricted in any way in that regard. That's awesome.
Oh, you're muted, John.
Yep, now I'm unmuted. Great. Okay, so that's the generated code. Where's the, can you show me the consumer code for working with geolocation? Do you have?
Yeah, absolutely. So let's look at, all right, so in the demo app itself, I've got all sorts of little kind of pages here. There's the geolocation position page here. So here's what this looks like. So I'm trying to see where it pulls in. Okay, so this one, we've got a geolocation position and a geolocation position error. So one of two things. We've got position options, which is an optional parameter that you can pass into this. So on initialized, geolocation is available to us. And I think I'm dependency injecting that into, up here. So inject I geolocation service. So inside here, we'll basically, you know, build out the geolocation. And once we have it, we'll plot it onto a Bing map. So I actually have Bing maps to show what that kind of looks like. But the actual source code just says geolocation, get current position, and then you pass in the component, which is this, and then you pass in the names of the success callback or the error callback and the options. And these two are marked as JS invocable. And this is like this is very common, like Blazor, you know, bidirectional JavaScript interop. So using JS invocable and, you know, passing in a component reference, but a more kind of appealing approach would be inside the sandbox. This is where I was testing out the same type of thing, but instead using the callback approach. So there's overloads in there. So we can say geolocation service, get current position, and then pass in a Lambda expression that says, here's the position. It goes to the assignment of the position. And then since this is, you know, we don't know when it's going to be called back, we have to call state has changed, or if there's an error. So that's kind of how you consume these things, just like you would consume any other service.
Right. Okay. Nice. So for any of these, then there's consumer code. I use the, I'm going to add in a NuGet package. And then I'm going to, in my in my program CS, I'm going to I'm going to wire up that middleware. And then in my actual page, I'm going to inject. So inject whatever service, and then in my code behind, or whatever we're calling it nowadays, but in my code file is where I'm going to just respond to those things. I'm going to respond to events. I'm going to call into the service and
absolutely
just deal with a normal service. Nice.
Yeah. So actually, I created like a to-do. To-dos are very canonical as well, right? By using local storage, I created a to-do kind of page. So when it's initialized, all of the keys in here follow a very same kind of pattern where I just prefix them with like a to-do hyphen or like task hyphen, and then their hash code, since I'm using records, since that's fully supported as well. You can use records to persist, or strings, or any type, any generic you want. So I kind of build out like a to-do functionality using local storage. So the local storage service, I get the length for it. We iterate through the keys. We return if it's, it matches the stuff. You can add them, so that's just, local storage dot add or set item, or local storage dot remove item. And then I also interleave session storage in here too, because, as for the demo app, there's different, text fields on different pages that, as the user types them and they navigate away and come back, it'd be nice if they're still the same way they were before. So I'm using both local storage and session storage. I'm doing speech synthesis because that's always fun. So you can do read to me, that's this page here. And this actually uses local storage. It uses the speech synthesis voice, which is source generated. Let's see here. So this is using all sorts of stuff. Like it's using the iSession storage, the local storage, and the speech synthesis storage. So we get all the voices, because there's different voices that are available. So you have to ask the native, the JavaScript code, like, hey, what voices do you actually have available? And you can register then for when voices have changed to get notified. So that's essentially a callback. And then you can ask local storage, get the item for this key. And if it's available, assign it to your local, state object that you have. So like the selected voice, the voice speed, the text to show, and this is coming from session storage. So it's pretty neat to see all this stuff. Like here, so here's speak. So speech synthesis dot speak, given this utterance, and it will call back and say, here, once it's done being spoken, here's the elapsed time. Here's how long it took, right? So you can do all of these things. So let me stop sharing this screen, and I'll actually show the demo page. So let me stop share this one, minimize that. All right. Whoops. No, stop sharing, not that one. Share screen. Share. Okay. All right, so you can see the screen, right? So this is Blazorators. This is the project, and the project, the sample code that we were looking at is actually Blazor WebAssembly, and that Blazor WebAssembly code lives inside the samples directory. And I've got a GitHub action that I put together. John knows I'm a big fan of GitHub actions, but what we're actually doing is we're compiling this WebAssembly application using these source generated packages, and we're deploying that to GitHub.io. So there's actually a website right here, which I have loaded. And this is the application. So this has all the sample code that we were looking at. So here's the to-do list. So these items right here, they've been in my browser for a long time via local storage. So I can create a new task, right? I can mark that as complete. If I go back home and come back, it's there, it's completed, right? I can delete it. And then if I go back home and come back, it's gone, because this is using local storage. Geolocation, this is gonna first, I've already given this app permission to my geolocation, so it actually uses the cached secure context. So this is showing the date time stuff, coming through. This is showing like the JSON response, kind of exemplify what it looks like. And then I have a big map that actually shows right where I live. And then we've got text to speech. So this dropdown is actually populated entirely from the JavaScript APIs that return those values. So these are all the different names. The selected, I've got Microsoft ARIA as the selected voice that I wanted. That selected voice is actually persisted using local storage. The voice speed is also persisted using local storage because it's just my user preference. If I have this text right here and I want it to be read, I hope this comes through. I've shared my audio, so I'm going to have it speak.
I don't believe we can hear it.
Yeah, so it's one of the settings. If you want to, you can unshare and reshare, or you have to share it with audio.
I thought that's what I did. Let me try it one more time. All right, let's try one more time. No? Okay. Well,
people watching live can try it themselves. Going to that link.
Yeah, they can go test it out themselves. But yeah, you can change this to whatever you want. So like, there's a default value. If I just change it and then I go here and then come back, you can see it's the same text. And the reason that is because we're using session storage to do that. But yeah, that's basically it. So there's a demo page. There's lots of plans. Again, this is a call to action for the community. It's not perfect by any stretch. There's lots of potential things that it could be improved upon. But hopefully this is inspiring. Hopefully, people watching this are excited by some of the potential things that you can do. So let me actually share the slides again.
So it strikes me like that you're showing two things really here. One is a technology or a way of turning any TypeScript definition essentially into C# wrapper to call into that as a service.
Mm-hmm.
And then two is you're showing here, I've done it with a few different things, local storage and like text-to-speech, geolocation.
Mm-hmm.
So I have a few questions on that. One is, if I've got I think it was Robert McLaws asked this, but somebody else has a specific TypeScript definition, how easy is it for them to say, well, I want to do this. I've got my definition. Now I want to use it on my specific library.
Right. The end goal is to have that be really, really simple. Ideally, I'd like this to be something where whoever is looking to generate, JavaScript interop code, they can use this package, the source generator package, and then generate the stuff that they need. And then the other part of this project is to build out some kind of example projects that show how to use it, right? How powerful it is, and kind of almost be like a test bed, so to speak. But there's published packages. So all those packages are published right now. They're out on NuGet. So you can consume either the source generator or the stuff that is the result of a source generated package. So yeah, this is the
over
resource.
Time you could get like a dozen or whatever. You could get a ton of different ones. Would you potentially ship those as like a get them all? Like here's a, what I mean?
Like a meta package, so to speak.
Yeah.
I haven't thought about that. I'd be curious what, from a consumption standpoint, like who's going to be using what. And I mean, these packages are actually tiny. They're really, really small. So, but they're super powerful. So I guess I don't know. I'm curious. You tell me, like, what do you think the community wants, or, is there a use case for that? But yeah, cool. Sky's the limit.
Okay, we have a couple of questions in the chat, and of course, if you have any questions, feel free to leave it in the chat as well, and we'd love to answer them as well. But the first question here is this individual asking about using source generators in real scenarios, like integrating with Octane framework, which is built atop Blazor, and how they can get started with source generators more generally.
Yeah, that's a really good question. So inside my Blazorators repository, the README actually has links at the bottom to various source generator, kind of guidance. So if you're not planning on using Blazorators or you want to try to do your own sort of thing, that's certainly encouraged. But there's a source generators cookbook and a source generators design document. And both of those have been really, really helpful. I think those were put together by the C# language team and the Roslyn repo, but they're there to kind of help you see how you can use source generators to do various things. Yeah, I guess I'm not really familiar with the framework that they're referring to, though, so I'd probably need some more details. But feel free to message me or DM me on Twitter. I'm always happy to reply and take a look.
I shared the link to that cookbook in the chat. And then Octane is an interesting. So actually, we had a previous show with Sean, who was the original creator of .NET Nuke DNN, and then he's taken a look at building it's a pretty cool system. It has CMS, but a lot of other stuff kind of built on top of it, and it's all built with Blazor. So
awesome.
That's really good. So I have a question for you. So we've talked about how Blazorators is integrating with Blazor Server as well as WebAssembly. Are there any plans in the works for integrating with Blazor Hybrid or Maui?
That's a really good question too. So for transparency, I've met with Dan Roth. I've met with Steve Sanderson. I've met with many other various stakeholders. And the consensus is that this is, as of right now, it's like a community project, but I don't know what the future is going to hold. So plans are more or less just, kind of like, hey, I had an idea, if I have an evening, I'll go to try to do it. But I've been really heads down working on my book. So that's why it's a call to action. Like if there's the community members that see this and they're like, hey, you know what, I'd like to kind of take what's here and build upon it or add features or, make it, part their own. Let's do that. Let's have those, collaborations. And I'm always happy to have an open dialogue.
So say somebody watching, they're like, yes, I am interested. I think we should have a library that works on audio synthesis or whatever.
Yeah.
Best way, like file an issue on the repo.
Yep. Absolutely.
Okay. And if they want to start contributing to the project directly, is there like a getting started guide, or where would you recommend these start off with?
Yeah, I don't think I have like a contributing markdown file. That'll probably be the next thing I add. But it depends. So, there's, as John alluded to before, since there's two different facets of the evolution of this kind of hackathon, one is building out the internals of the source generator itself, adding different parser implementations, to support like WebIDL, or actually making like the TypeScript type declarations, a lot more solid, because right now it's kind of a string cheese, regex mess. So, if it's an emphasis on building out the source generator stuff, that's fine. Again, create an issue and let's have those discussions. Or if it's, even adding a package, someone could come in here and say, I have this package idea. Let's go point to this declaration file, and, it would source generate it. It'd become part of the build context and published in NuGet. So it's, it all starts with an issue on GitHub.
Okay, makes sense. We have a question here in the chat. This person is asking about where do you see this being used? So is this for large existing JS modules or for something else?
I guess I see it being used wherever it's useful. So if right now it doesn't support modules, imports or exports, stuff of that nature, there's that is some of the feedback that I've received from the Blazor team and others. But that would be ideal. I think it'd be awesome to eventually get it to a place where you can, point it to any arbitrary, type declaration, whether it's a module or whatever it is, and it just generates it. And I want it to be looked at as being basically JavaScript bindings that are source generated for any consumer of from .NET to JavaScript. So I think there's a lot of room for that.
Okay, makes sense. Okay, I think that's basically it for the questions in the chat. Yeah, I think that's it.
Awesome. Yeah, I
did
just
you-
will plug this
Did
real
you want to
quick.
share this? Yeah.
So I was sharing the various resources. There's different links to NuGets and whatnot. A use case for source generators. This has actually become what I've written for chapter 7 in my upcoming book. So the book is Learning Blazor, Build Single Page Apps with WebAssembly and C#. It's currently in early release. Yep, check it out. Otherwise, yeah, that's all I've got. So thanks for having me. This has been great.
Yeah, thank you so much for. Sorry, John, go ahead.
Yeah, so I just wanted to let people know too, we've got a VS Toolbox coming up in a half hour. So you may want to take a coffee break and start playing with Blazorators and then hang out, come back in a half hour. I think this one is, I think if I remember, let me look real quick. It's a cool one. I remember that. It is, yeah, Syed's going to be showing web development in Visual Studio 2022. So anyhow, I had to give that little plug.
That's awesome. And yeah, I think that's basically it for today. Thank you so much, David, for showing us everything amazing about Blazorators. It's been really interesting and insightful. I think that basically wraps up for today. So once again, thanks, David. Thanks, John. And thanks, everyone, for watching.
Thanks for having me.